Welcome guys, we are still on streams and today we want to see what we can do with primitive type string, which is the specialization of the stream interface. So I have a couple of classes here that I want us to look at and see how far we can go. So let's look at what we have in here. As we can see here, we have a function called min-max sum, and what we do is just calculate the mean, the max, and the sum, then we just do the printing, and we are passing that function an array of numbers. So I'm just gonna put the other one here. So as you can see here, we are using primitive type string like for all of this operation. When we calculate the minimum, we actually convert our stream of integer to a long string, and we apply the limit here to say we only need 4 values, and that means only 4 values will pass here, and then we calculate the minimum of actually this long string. So as you can see here, we don't pass the the comparator to calculate the minimum, because the long string already knows how to calculate the minimum of the stream of long values. So we don't need to give it a comparator to know how to know that this is the minimum number. The same goes when we are calculating the max to pass the comparator. So if I was to come here and remove this, you see that we have a problem here. This minimum wants us now to give it a comparator to say, how do I know how to compare the objects in this stream. So since we know that it's an integer, we can pass integer dot compare to. Then we know that this actually will return an optional, so it will return something like this. So this is what we have to do now. Then our class works. So I hope you can see the difference here. If it's a primitive type string, we don't have to give a comparator, because we know that we are working with primitives and we know how to find a value. But if it's not a primitive type string, we have to pass a comparator. And we already discussed the method references, so we know what this means. So I will go back to what we had before quickly, and I'll just remove this, and we see what we are having here. So here we are calculating the minimum, the maximum, and we're calculating the sum. So if you can look at the primitive type string, all of them, they have this method called sum, because you can actually be able to sum them. They are primitive types. So if I come here, you will have this method sum. You have and sum is a terminal operation. That means it will consume the stream. Then we also have min. It's also as we saw in the max. Then we also have a count. We also have an average, and observe that average will return OptionalDouble. And we also have long summary statistics. We will look at this one a bit later, what it does for us. We looked at any match and all match and the other ones. So I wanted to show you that. So basically what we are doing here, we get a stream, we box that stream, then we sort it. Then after we sort it, we convert it to a long stream, Then what we do, we limit the number to 4, then we get the maximum value. Sorry, the minimum value. So based on this, the minimum value here should obviously be 1. And if we check the max, because of the limit 4, the maximum value must be 4. The sum here, we skipped one element, which means it would add all these numbers for us. So if we were to print this, so observe here, we are just printing this object min and max as is, of which we are not supposed to do. You will see what happens if we run this code. So I'm just going to run this code quickly. You see? Yeah, so guys, if I run this code, you see I get optional 1, optional 4, and 35. And this one is 35. So now the question is, why do we have this optional 1 printed and optional 4 printed? So remember what this does here. It's a string formatting that we did earlier on. So it will convert this to a string. So it will call a toString on this particular object, just because I put an S here. So now it tells me that inside a toString of OptionalLong, they probably have this kind of a setup. So let's go and see that. OptionalLong, and then we wanna search its toString method. toString. So you see, we have OptionalLong, and we have this bracket, we have the value, we have this. This is why it's been printed here. If the value was empty, we were gonna get empty here. So if I was to have this and I run this code, as you can see, we have empty here, because there is nothing, which is actually defined in the toString here. That's why we get in this value. So we know that there is a way to get this value using an optional. I already discussed that with you. What you can do, you can say get as long, okay, and then here you can say get as long as well, or then if you run this code, now you get the actual values. But observe here, if we say 0 here, that means we don't have nothing there. So that means the get will have to throw an exception, because there is no value there. Then it comes to that if present, if is present, use those methods as you saw in our previous videos. So if now, what I can do here, I can say or else. So what I'm saying is that if it doesn't find the value for minimum, it should just give me 0. So if I run this code, it will give me 0. It means I didn't find the value. Or you can do other things. You can say, as you will see here, as I said, you can call this method is present, or you can use if present, and all that to do whatever that you want to do. You saw how we use the if present and is present, but you are not advised to use the get as long directly, or rather you can use this one that I used here before. So I'm just gonna go back to this one and run this code. So as you can see, these functions are pretty much the same. They don't differ that much. Then what I want us to do now, let's look at this other class. So as you can see here, we have double stream of, then we give a list of doubles, then we box that, we convert it to a list of to stream of double, then we collect that, it becomes a list of double. Then if we run this code, we're gonna get the printing of 1, 2, 3, 4, 5, just like that. Then even numbers. So what we are doing here, As you saw, we already saw how range is used. It's gonna take numbers from 0 to 9 because it's not closed. If it's closed, it was gonna be 0 to 10. Then what we do is that we check those numbers. If they are even numbers, then we print those that are even numbers. So if I run this code, this should be pretty straightforward. 0, 2, 4, 6, 8. Then I can come to this one also. So what we are doing here, it's pretty much what you saw in the other one. We have system.out.print, we have in stream of, then we have 2, 12 and 3. So we want the sum, so we are going to get 15 there. Then also here we have a to string, so we have a stream of 3, 2, 1, 7. We sort that, we find to array, then we print that. So we're going to have to print 1, 2, 3, 7 here. Then we have a range here, we say 10 dot 2. Maybe what we can do here, can just add. So what I can do for now, I can just comment this code. Alright, then I can run this code to see that we're gonna get 15 here printed for us, which is fine. So what I want to do now is I want to comment this one to see that here we're going to have 1, 2, 3, 7 printed for us on the screen. As you can see, that is. And then here what we are doing is we have range 10 to 1000. We know it's exclusive for 1000. Then we apply a reduce function. So what the reduce will do for us, so what I can just do now is I can say 0 to 10, just to make it a bit easy. What reduce will do is it will add numbers from 0 to 10. So it will say 0 plus 1 plus 2 plus 3 until it reaches to 9, because 10 is not inclusive. Then it will print the answer for us. Let's see how much we get. We get 45. Okay, if we were to put 2 here, we're gonna have 0 plus 1, that is 1. So 2 is not included, so obviously we have to get 1. But if we were to say closed, 2 is included, we have to get 3 as our output because of the reduce. So this reduce method, guys, it's a terminal operation, which means it consumes the stream. So you see here that we were to apply parallel. So let's say we were to add, let me just say 0 to 1, 2, 3, 1, 2, 3. So we have 2 million. We want to add these numbers. Let's run this code. Okay. We see that we are kinda like since it's a bit fast, so we won't really see the difference. So I'm just gonna put this number. See, we waited a bit. So if you make it parallel, it means this will be divided into chunks and the result will be a bit faster. Yeah, so you might not see that for now, but I've already demonstrated the use of parallel in our previous tutorial, so that shouldn't be an issue for now. So I'm gonna comment this code also and uncomment the vectorial. So if you want to calculate the vectorial of a number, let's say we want a vectorial of 5 int x, then we can put 5x here. Then what do we do? Okay, it shouldn't be x, let's say number. So what we need to do now is, okay, we just need to run this code. Factorial of 5, I think it's 120. Yes, it's 120. And we are using a reduce. Also, all we do is say x, then we say x multiply by y, which means we calculate the first number and the next number, then we keep, and then it actually accumulates. That's what reduce does. So the previous answer you got when you say x by y would be multiplied by the next number on the stream. Hence you get this number. So this is how this actually works. Let's see what we have here in stream. There isn't much, so we also have range here. Then we say stream.box, we box it, and also we see that we can have two streams concatenated together. So we have stream 1, we have stream 2, sorry, then we concatenate stream 1 and some other stream, and then we print everything in stream 2, which is a concatenation of the two. So if I run this code, I should get 389 gigs for gigs. 389. Okay, let me see. Oh, it's not the function I'm calling, so I should call this function, sorry. Okay. Oh, it's the range, I forgot. So what should happen is you have to print numbers from 3 to 89, then you print gigs for gigs because of this range function that you have here. Then we also have this one here. So I'm just gonna call it quickly. It's P3. So what we are doing here is we have list of strings. We have Java and OCP. Then we get a stream from a list. We already saw how we can do that and what this means. Then we filter. We want the length of each string should be greater or equals to 3. Then we map the length to the length, which is actually we are mapping to int stream. So then we sum that. So basically here the answer should be 4 plus 3, because here we have 4 characters, we have 3, so it should be 7 when we run this code. And as we all know, there is a better way of writing this with using method reference. So you can say string.length. So this should still work for you. Fine.